Assalamualaikum and a very good afternoon. I bid to my lecturer Prof. Jinak Selamat and to my fellow friends. Today, me and my partner Nur Fakira Hidayati are going to present our hazard plan for step 12 and 13 from group doughnut. So this is our product, which is bird nest drink with rock sugar. Our company is Grand Imperial Bird Nest Holdings Sdn Bhd. So this is our product description, which is the bird nest drink. The moisture content is 11 to 15% with relative humidity 60%, chlorine level 20 to 60 milligram per liter, pH level 4.5 to 6.5, nitrate level less than 0.07 milligram per kilogram. We also have a microbiological limit, which is Staphylococcus aureus less than 1.0 times 10 to the power of 2 and E. coli less than 2.5 times 10 to the power of 3. The shelf life of this product is 3 years in room temperature at 20 to 24 degrees Celsius. Our intended use is general consumer. So the processes have been mentioned below. So my partner are going to present further about the process. So Fakira, are you ready?
Yes, I'm ready. Okay, thank you for my partner, Fatin. So this is our process for bird nest drink. The process will start with the receiving of raw bird nest, rock sugar, stabilizer, water, bottle gas, and box. So from the receiving process, there will be a visual inspection. If there is any defect, there will be rejection and be returned to the supplier. And then we will be sorting out the bird nest into the grade. And this is the first step of the processing of bird nest, which is the brushing, picking feathers, trimming, molding, cleaning, and then there will be a process of drying. Cleaning will be by using water, and then we'll do drying, and then there will be a quality inspection, and there is the final product is the clean bird nest. After that, from the clean bird nest, there will be wet mixing. Wet mixing is the mixing with the water, and also with the others product. And after that, there will be fillings. Fillings will be the adding of water. Okay, there will be the mixing the stabilizer, sugar, and the bird nest. And then there will be fillings where the product solution with water will be filled into the bottle, and then the capping, labeling, and then we sterilize the product, cartoning, and then we send it for quality inspection, storage, and loading for delivery. If everything is okay, and then it will be delivered to the next production. So secondly, we'll proceed to the hazard analysis. So for the hazard analysis, okay, this is the hazard analysis of the product packaging material, which is the glass bottle and the box. Here there is a significant hazard for the box, for the glass bottle, because it is potential for cuts and personal effect to the personnel. However, it is not a sensitive material because there is a way to control measure on this particular hazard. So next is the hazard analysis for our material, which is the raw bird nest. For the raw bird nest, there is a significant hazard due to the presence of Staphylococcus, E. coli, and nitrite. And it has been determined as a sensitive material because if there is any hazard in it, we are not the one who processing the hazard. So it is a sensitive material. So next is for the rock sugar, stabilizer, and water. there is no significant hazard and there is no other sensitive material. So that is the continuation for hazard in water, which is the chlorine, the chemical of chlorine byproduct, and the physical foreign matter. And then I proceed with the process step, hazard analysis. As you can see, there is a significant hazard for receiving raw bird nest, which is the Staphylococcus, E. coli, and nitrite. However, the CCP has been determined that they only come from Staphylococcus and nitrite. So next is the sorting, brushing, and picking feathers. There is no CCP in this process, but there is a significant hazard for Staphylococcus and E. coli. Next is, okay, this is the next process, trimming, molding, and cleaning. And here there is another CCP, which is the cleaning, where we are using water. And however, the cleaning CCP came from nitrite, which is naturally from in the bird nest. So next is the process of drying. Drying is another process that is a CCP because the presence of Staphylococcus and E. coli. And yeah, there is a CCP here. Okay, and then next is for sterilization of bottle and sterilization of bird nest product, bird nest drink, our final product. There is a CCP for both of this product, for both of this process. I'm sorry. Okay. Next, lastly, this is our final process. There is no other CCP except for the continuation of the sterilization of here E. coli is this, the continuation of sterilization of bird nest drink. Okay, and I will pass to my partner to continue the presentation.
Thank you, Fakira. So I will present about the critical control point. So we have 5 CCP here, which is receiving raw bird nest, cleaning raw bird nest, drying, sterilization of bottle, and sterilization of bird nest drink. So why do we have empty space at the Q3 and Q4 here? It's because based on the CCP decision tree, if the first question Q1 is yes, we will proceed to the Q2. And if Q2 is also yes, it is automatically declared as CCP. So that is why the Q3 and the Q4 is empty here. So I will proceed with the control limit. Our control limit for receiving, which is the significant hazard, is Staphylococcus aureus and nitrite. So the tolerance level is for Staphylococcus aureus is less than 1.0 times 10 to the power of 2, and nitrite level, which is less than 0.07 milligram per kilogram, as have been mentioned earlier in the product description. Next, I will proceed to the temperature of the drying. Temperature, it must be 65 to 70 degrees Celsius for 2 to 3 hours with a moisture content of 11 to 15% and relative humidity of 60%. Next, for sterilization of the bottle, the temperature must be 1 to 1.1 degrees Celsius for 15 minutes. And for sterilization of bird nest string, the temperature must be 160 degrees Celsius for 35 seconds. Next, I will pass to my partner, Fakira Hidayati, to proceed with the step 12 and 13.
Okay, so thank you, Fatin. I will continue with the establish of verification procedure and document control. Okay, so firstly, for the first CCP of receiving bird nest, there is significant hazard of biological and chemical, which is Staphylococcus and nitrite. For Staphylococcus, the control limit the critical limit have been explained before by Fatin. And here is how we monitor it by using the what did we monitor is the microbial count on raw bird nest by microbiological tests, and when it will be done for every batch of receiving material. And the one who will be monitored it will be transport supervisor, because he is the first person who will be handling the receiving product or a material. And for chemical, which is nitrite, we will monitor it by using the chemical analysis. Also, we'll be doing by every batch of receiving, and will be monitored by the transport supervisor. And if there is if there is a problem during the receiving process, the corrective action that will be taken is that we will be reject the bird nest that has exceed the tolerant level for both of staphylococcus and nitrite. And here is how we verify it. We will verify using the microbial count. How? Also the same, by using microbiological test, and it will be done for every batch of receiving material. And the one who will be verified it is the QN and QC inspector. The same goes for nitrite content level. Will be verified by using chemical analysis, and will be verified by the QC inspector. After the verification, the document that will be used to record it is by using the CCP1 form, the chemical analysis result, the supplier laboratory result, because as you have said before in the hazard analysis, if there is an exceeding level, the control measure is by we will be checking the laboratory result from the supplier. So the record will be kept safe in the document of supplier lab result. So the second CCP is cleaning, which is the significant hazard came from nitrite on the bird nest, and there is 4 critical limit here, which is the chlorine level, which is the concentration of chlorine chemical that is being using during the cleaning, the pH water, the time, and the nitrite level. So here, the one how we will be monitored for chlorine is by using chemical analysis. Same goes to nitrite, and for pH is by using pH meter. And for the time, we will be using the validation standard. For time, the technician will be the one who will be monitored it. pH and chemical, for chemical chlorine and nitrite, it will be monitored by QC inspector or production supervisor. And all of this monitoring process will be done for every batch of cleaning process. Every time we will clean a bird nest, during the process, it will be monitored. Same goes for the verification process, which is we will be verified it for every batch of cleaning process. What will be verified for chlorine level, pH, and time is by using the control point. How? By using the GMP control SOP, or we follow the standard operation procedure that has been given by the company. And the one who will be verified is the production supervisor. For nitrite, will be verified by QC inspector. The record that will be used document is that CCP2 form, maintenance log, because there is technician here. Maybe there will be another technician that will be taking over. And then the chemical analysis record, and the daily production line. And next, Fatin will continue with the next part.
Thank you, Fakira. So I will proceed with the CCP3. So the biological hazard is Staphylococcus aureus and E. coli. So same as have been mentioned earlier, we are measuring the microbiological count by using microbiological tests. It will be done by QC inspector or laboratory assistant. As for temperature, the temperature must be set at 65 to 70 degrees Celsius. What How we measure it is by temperature control by using validation standard done by the technician. Time and relative humidity will also be measured. Time we use validation standard, while relative humidity we use electric hygrometer done by production staff and QC inspector for every batch of drying process. So how we verify it? Same as for microbiological count. As for the temperature and time, we use control point by using GMP control SOP and follow the standard operation procedure done by production supervisor. As for relative humidity, we are measuring the control point by using GMP control SOP and follow the standard operation procedure done by production supervisor too. All these have been done by QC and QA inspector, production supervisor for every batch of drying process. So the record that we use is CCP3 form, maintenance log, laboratory analysis result, microbiological test record, daily production line form, and record of processing time and temperature. Next is CCP4, which is sterilization of bottle. So the biological hazard is Staphylococcus aureus. So we must set the temperature at 1 to 1.1 degrees Celsius for 15 minutes. So we measure the temperature and time control by using validation standard for every batch of sterilization process done by the technician. How we verify it is by using control point, by using GMP control SOP and follow the standard operation procedure. We also can use microbiological tests for every batch of sterilization process done by QA inspector. So the record is CCP4 form, maintenance log, daily production line form, laboratory analysis result, and record of processing time and temperature. Next, I will proceed to CCP5, which is the last CCP, which is the sterilization of bird nest string. The biological hazard is Staphylococcus aureus and E. coli. We measure the microbiological count in the product by using microbiological analysis for every batch of sterilization process done by QC inspector. The temperature, we also measure the temperature and time control by using validation standard done by the technician for every batch of sterilization process. How we verify it is by using microbiological count on bottle and microbiological test done by QA inspector. And for temperature, we use control point and GMP control SOP, which is follow the standard operation procedure done by production supervisor for every batch of sterilization process. So the record is CCP5 form, maintenance log, daily production line form, laboratory analysis result, and record of processing time and temperature. So that's all from both of us. Thank you for listening.
Thank you.